Hey guys, Mrs. Dan. So today is the start of a new unit, Unit 7, the Pythagorean Theorem. Lesson 1 is the very basics of the Pythagorean Theorem. Today you will need a calculator, so if you haven't gotten one, please get that out now. Also copy down the objective on the lines provided and do the do now, and I'll go over it with you in a few minutes. So if you haven't copied the objective, please get it down. I wrote it here. My objectives actually are always pretty important. This one I really like because it tells you what you need in order to use the Pythagorean theorem. You do need to know two sides of a right triangle. Okay, so the Pythagorean theorem works if you know two sides of a right triangle. So that's how come I like you writing my objective. When you did the do now, hopefully you said that this turned out to be 9. This is 16. And then on number 3, I did have to round. So if we take a look at what the calculator says for the square root of 56, I see it's an irrational number because my screen is full of digits. It tells me in the directions I can round to the nearest tenth. So I will write 7.5. And then finally, 7 squared plus 24 squared equals, and you probably did this quicker than I did, 625. So we just got done with the unit where we did some squaring, we did some square rooting, and now we're going to use it in order to find missing sides of a right triangle. So the Pythagorean theorem does tell us the length of sides of right triangles. It has to be a right triangle. The Pythagorean theorem is very limited in that it only works on right triangles, but it really is such a cool thing that people recognize this so that we can find missing sides. Honestly, when you're building things like construction workers actually use the Pythagorean theorem because they have to make sure when they build like a wall that it's perpendicular to the floor, right? We want the wall straight up and down. We don't want it a little tilted. So they do use the Pythagorean theorem. They might not call it the Pythagorean theorem while they're working, but they actually are measuring the lengths of sides in order to make sure it makes a right triangle. So in this triangle, you are supposed to measure the lengths with a ruler in centimeters. So I'm not going to tell you to go get rulers. I measured them already. And side A turns out to be about 8 centimeters. Side B turns out to be 6 centimeters. And side C turns out to be 10 centimeters. So A we said was 8, B is 6, and C is 10. And I'm asking you to do the calculation of side A squared and add it to side B squared. And what do you get? So hopefully you said 100. 8 squared plus 6 squared. 64 plus 36 is 100. And then in part C here, it asks how does the value in B, meaning this 100, how does that value relate to the value of C? So side C is what they're talking about. Do you see any kind of relationship there? Hopefully you're noticing that if you take side C and square it, side C squared actually is 100, right? Side C squared actually equals side A and side B squared. And this is something that people recognized many, many, many years ago. There's actually proof on um, in the Egyptian times, there's like writings on like tablets and stuff that they found that show that they had some knowledge of this side a squared being added to b squared actually equals c squared. So when you add two sides of a triangle squared together, it equals the third side squared. Now, back in those ancient Egyptian times, it was not called the Pythagorean theorem. Pythagoras is a famous mathematician who mathematically proved that this actually works for all right triangles. But people noticed this before Pythagoras was even born. Notice that there's this kind of relationship. So this is something that I really want you to remember. You have to memorize that it's called the Pythagorean theorem, and we say that side a squared plus side b squared equals side c squared. Now, sides A and B, the sides that make this right angle, side A is called a leg of a triangle, and side B is the other leg. So there are two legs to a right triangle, and then across from the right angle, like you could draw an arrow to the side across from the right angle, that side that we're labeling C is actually called the hypotenuse. You do have to know this terminology. There'll be questions, maybe like multiple choice questions, about some of this terminology. So A and B are the legs, C is the hypotenuse, and if you square the legs and add them together, they equal the hypotenuse squared. And then we could just do calculations with this, but sometimes people are like, yeah, really, Miss Stan, does it work for all right triangles? And the answer is yes. And there's this cool little video that I'd actually like to watch that kind of shows us with pictures that it always works. So I'm actually going to talk you through this little clip. Someone is starting with this right triangle, and they're going to show us that a squared plus b squared equals c squared. So she's writing the Pythagorean theorem, and when you square the hypotenuse, that is supposed to equal the longest side, by the way. So if you're squaring a hypotenuse, it means you could put a square on its side. And then if you square the leg, we could put a square on its side. And if we square the other leg, we could put a square on its side. And she's going to call them slightly different letters than what we did. She's using H for hypotenuse instead of a C. And A and B is definitely still the legs that she's using. So we have a squared and we have b squared, which you could see she's marking up, and then this blue square is c squared. So she's cutting up the b squared into some pieces so that she can show you that she can fit all of these pieces on that c squared. Do you see that? All of square A and all of square B just fit on all of square C, which she called h squared. So it just kind of proves geometrically that a squared plus b squared equals c squared. Anyway, we're just going to practice some problems now using the Pythagorean theorem. Anytime you use a formula, such as the Pythagorean theorem, you should always write down the formula prior to plugging in any information. So here in exercise 2, we have a right triangle with legs of length 5 inches and 12 inches, and we're going to use the Pythagorean theorem. So let's write that formula down. A squared plus b squared equals c squared to find the hypotenuse. Now, the a and the b actually don't matter which is A and which is B. I could have made the 5 the A and the 12 the B, but the hypotenuse is always across from the right angle. So you could always draw an arrow across from the right angle and you'll find side C. So I'll write 12 squared plus 5 squared equals C squared. So just make sure you remember that you take the side and you square it. And you add it to the other leg and you square it. And then it equals C squared. You have to write in those squares. So this is 144 plus 25 is what C squared is. So now we add 144 and 25 and we get 169. So C squared equals 169. Remember that video that we just watched? If C squared equals 169, that's really like a square on here whose area is 169. I need to know the side. So we need to square root. If you remember back to our other unit, when you see something like C squared equals 169, remember how we would take the square root of each side because the square root cancels out the square, because square rooting is the opposite of squaring. Also, what we did was remember that all numbers have 2 square roots. So if you put your own square root sign in there, remember you're supposed to put that plus and minus in front of it. So C equals either positive 13 or negative 13. But since this is about the side of a triangle, can a side ever be negative? No. So when we do the Pythagorean theorem, we actually always ignore the negative answer. So C is really 13, and we'll use proper units, 13 inches. The length of the hypotenuse of this right triangle is 13 inches. Every single time we do the same process. Some people actually really like the Pythagorean theorem because it doesn't really change very much. It's just the same thing again and again. So in exercise 3 part A, we'll write the Pythagorean theorem. A squared plus B squared equals C squared. What can I use for A? Sure, I could use 12. What could I use for B? Sure, I could use 9. Notice how I'm squaring the sides also. Across from the right angle is my side C. So this is 144 plus 81 equals C squared. Combine like terms. 225 equals C squared. But the opposite of squaring is square rooting. So we have to square root both sides. I always put the plus and minus because I'm so used to it. But I also know with the Pythagorean theorem that it's only going to be the positive answer. So the answer will be 15 centimeters. 15 centimeters. And I'll write that along the side. 15, oh, not centimeters, inches. Sorry, guys. 15 inches. Because I did A squared plus B squared equals C squared. And I knew off the top of my head that the square root of 225 is 15. So on letter B, I know that this could be A, this could be B, across from the right angle has to be C. I write the Pythagorean theorem, A squared plus B squared equals C squared. So I'll write 10 squared plus 8 squared equals C squared. 100 plus 64 equals C squared. 164 equals C squared. Now, I don't think 164 is a perfect square. I don't have that stuck to memory. Let's see. Square root of 164. Yeah, it's irrational. So look at these directions. If the length is irrational, round to the nearest tenth. So on my calculator, I could see it's 12.80624847 dot dot dot. I know that it goes on forever, but I can round to the nearest tenth. So I'm going to say C uh, is about 12.8. Now look what I just did. I kind of went from this step to this step. I didn't write my square roots in. I just did the square root. I would accept what I did um, as full credit on a test. I did show that I was using the Pythagorean theorem, and then when you go from here to here, it's kind of like I have to assume that you know that the opposite of squaring is square rooting. Should have I maybe said that we do the square root of both sides like this? That probably would have been nice, but like I said, if I would accept this, then I have to accept it from you. All right, next, exercise 4. So exercise 4, we have to actually like solve an equation. Again, kind of what we did in our last unit. And the reason why we have to solve an equation is because look at across and a right angle is C, and this time they gave us C. Right? And the other problems, I was finding C. I didn't know what C was. So let's be real careful with this. So I'm going to call this side A and call this side B. Remember, honestly, it doesn't matter which is A and B, but let's make our notes look the same. So if I use A squared plus B squared equals C squared, and just substitute in the information I know. I don't know what A is, so I'm just going to keep it an A squared. Some people like to put it as an X squared. It doesn't matter what variable you use. But in place of B, I'm going to put an 8. And it gets squared, of course. And in place of C, I'm going to put the 17. And it gets squared. So now I have A squared plus 64 equals, what is this? 2 something. 17 squared is 289. So now I cannot square root each side yet. Remember, we're supposed to isolate the variable. I have to get that A by itself, so I have to subtract 64 from both sides. Just like we've solved equations in the past. You undo your adding or subtracting first. I get that A squared is 225. I do have this one committed to memory. I know the answer is 15. I'm going to show all of this work, though. The square root crosses out the square. I'll put my plus and minus. A is positive or negative 15, but of course a side of a triangle can't be negative, so A must be 15 feet. Always trying to remember to put your units. Let's do B together. I'm going to call this A, this B, and this C. So A squared plus B squared equals C squared. 14 squared plus B squared equals 20 squared. If ever I'm going too fast, just hit pause. 14 squared is 196. I don't know what B squared is. Be careful with these B's. Sometimes they look like 6's. And then 20 squared is 400. Again, I have to get B squared by itself. So let's subtract 196 from both sides. So B squared equals whatever 400 minus 196 is. Which I don't think is a perfect square. So when I square root both sides, I'm going to have to round. B is about, it does say right here, round to the nearest tenth, the square root of 204 is about 14.3. and only the positive exists. Yes, all numbers have two square roots, but when we're dealing with triangles, side lengths have to be positive. So side B is 14.3 feet. And finally, a geometric application. So squares and rectangles have right angles in them, right? There's right angles in all four corners of both squares and rectangles. So when we draw a diagonal, we actually create two right triangles. If I connect this corner to that corner, I just made two identical right triangles. In this rectangle, if I connect the corners, I just made two identical right triangles. And a lot of times they ask us to maybe find the diagonal. In this case, they're asking us which of the figures has the longer diagonal. Now, you can't go by how it looks, right? These squares and rectangles really aren't drawn to scale. Maybe, excuse me, maybe the square has a longer diagonal, maybe the rectangle has a longer diagonal. The only way I could tell is if I find side C using the Pythagorean theorem. So I'll do the square first. A squared plus b squared equals c squared. 5 squared plus 5 squared equals c squared. So 25 plus 25 is c squared, which means this adds to 50. C squared is equal to 50. I want to know what c is, so I'm going to square root both sides. And actually, I'm not even going to change it to a decimal because they're not asking me how long is it, they're just asking me which one is longer. So on the square, side C is the square root of 50. I can leave it just the square root of 50 actually, and you'll see I'll be able to make a very easy comparison. So let's do the rectangle. I'm going to call this A, this B, and of course from the right angle is C. So a squared plus b squared equals c squared. 3 squared plus 7 squared equals c squared. 9 plus 49 equals c squared. So 49 plus 9, it is 58. So now c squared equals 58. So when I square root both sides, c is the square root of 58. Which is bigger, square root 50 or square root 58? Of course, square root 58 is larger. And if you don't believe it, or if it's hard for you to look at it in square root form, then fine, you could go do it on your calculator. Take a look. Square root of 50 is that number. Square root of 58 is that number. I like how my calculator can leave all information on the screen. I could see that they both start with 7, but after the decimal, there's a 0.0 for the square root of 50, but a 0.6 for the square root of 58. Square root of 58 is definitely bigger. It's about 7.6 instead of about 7.1. So let's say that the rectangle has the longer diagonal. So a diagonal is that line you draw across the figure from one vertex to another. That's across from it. And we use the Pythagorean theorem. So you get to work on your homework. And if you need to rewatch this video, you do so. I'll see you soon. See ya. Bye.